We are live. Well, thank you for having a listen to this week's episode of Secure Insights with NDK Cyber. So very excited to be joined by Chris Hertz this week. Chris is the co-founder and CEO of Healer. Chris, welcome to the pod.
James, thanks for having me. Like you said, I'm Chris Hertz, co-founder and CEO of Healer. Started Healer with three other colleagues 2.5 years ago now. We all came out of Rapid7, where I led the cloud security business. I joined Rapid7 in 2020 through the acquisition of our company DivvyCloud, which was a CNAPP CSPM. And excited to talk about Healer today with you.
Very good, very good. So a ton of stuff to get into here. Thanks for the very brief overview there. So I
Yeah.
guess if we start at the top then, like where did this whole Healer journey come from? What was that problem that was so frustrating? You were like, we need to get this Healer thing off the ground here.
Yeah, it really came down. Look, at Rapid7, we were a publicly traded cybersecurity company. We had significant regulatory and compliance and security requirements really to address customer trust and deliver a good product. And there was this constant pressure, as every engineering organization will have felt, between shipping product quickly and being able to tackle the tech debt. And security issues are part of that tech debt. And inevitably, from a business side, you're given little time to address tech debt because you really are focused on trying to drive product growth, which will drive revenue growth. And we really sat down and were analyzing why we were always behind, right? Why couldn't we ever really get rid of the technical debt? And we started with that focus on open source security, which we saw was one of the more tricky, challenging ones, and was going to be even trickier as AI-assisted coding started to emerge with greater and greater usage. And I'll talk about why that matters later. But fundamentally, what we came down to was that open source security was really an economics problem,
Mm.
right? And the reason it's an economics problem is that fundamentally, the unit cost to fix was too high. So if you thought about the amount of tech debt that we have, just related to open source security, just related to being able to upgrade to a non-vulnerable library. If we looked across the tens of thousands of vulnerabilities that we saw on a regular basis and tried to do all the labor associated with that, it would have been years of developer effort, which of course we don't have.
Years.
Um,
Wow.
and and so why is is it so costly? It's because there's enormous amounts of research and analysis and uh, and effort just to understand whether or not a library upgrade can occur. What's the right library upgrade to perform? What's the impact of that library upgrade? Will it produce breaking changes? How do you resolve those breaking changes? That's the level of effort that's required for each individual one. And many times you even have software that's keep the lights on where you're not actively developing it. So you have developers who are not all that familiar with the code. And so it just becomes this enormous mess. And when you look at most organizations, what they've defaulted to is really this model of prioritization, which is to say, look, because the cost is so high, we're just going to try and shrink the list to the smallest number of things we think engineering can take on. It might be the right list. We can talk about that a little bit. But ultimately, we felt like the world shouldn't be in this position where we had to defer technical debt and defer and defer and defer and let it get more and more expensive, that we should be able to, using modern technology and some proprietary technology that we've invented, really to be able to get to the point where we can fix first rather than prioritize first and eliminate that technical debt rather than live with it. And that's ultimately the problem that we wanted to go out and solve for. Fundamentally, really build application security that can scale faster than AI can generate code, because that's the real challenge that organizations are facing today. And we saw that coming. I mentioned perfect storm, but I'll pause there. Happy to talk a bit more about the problem as it comes to where we saw regarding AI coding and open source, if that makes sense.
Yeah, of course, of course. I can't believe that stat. Years, if we were to sort of do it the way we're currently doing it, is insane.
Right.
It just feels. Is that because there's just so much noise and we can't just break through that noise to get the clarity on what
Well,
needs
the
fixing?
challenge is thinking about it from this perspective, which is that it just to evaluate. Imagine we have all this long list of vulnerabilities. your application security organization, which ultimately has the remit to understand those vulnerabilities, lacks a lot of context, right, to be able to understand them. Part of that is they don't necessarily understand the level of effort or the impact of that vulnerability, right? You have to take a vulnerability and you have to translate that back to a remediation or a set of remediations. You have to then look at each of those remediations in each of the code routes that they need to occur. You have to understand the dependency graph. You understand the relationship between transims and bundled dependencies, first-party libraries, all these things that impact um, um, all the permutations in which the library is entering the code and being used. And you have to then understand compatibility of a change, a library. So let's say I'm on version X and there's 40 additional versions ahead that I can upgrade to. I have to evaluate each one of those and say which one has the minimal impact but achieves the security outcomes I want to and I have to do that in the context of all the dependency graph of all the different usages of the library, and how that library is used in my actual code. And that just gets me to the point. All that effort just gets me to the point where I can say, is this something that we can do? And how hard will it be? And what's the level of effort that it's going to require and how disruptive will it be? And so you can imagine the challenge you have is if you went to a developer and said, hey, will you do this for me across 10,000 vulnerabilities, just to understand which of the things that we can go and easily upgrade, right? And which are the ones that are going to require additional effort. And then cross tabulate that with again, what's the most important of these things we could go do? It's that context is completely missing and wildly expensive to get. And so we
Yeah.
think about it as like you have to build a shared operating platform where all of that work is done automatically. So what you're delivered is a set of remediations, the difficulty of those, whether they would introduce a breaking change or a non-breaking change, the prioritization is well married there, um, and a clear upgrade path. And then that allows good, rational decision making to be made where you can say, hey, look, we can identify that 60% of these remediations will not produce breaking changes. And therefore, we can go and execute those, eliminate 60% of our technical debt right away, with interaction with the developer. So, ticket is opened, our agent actually does a whole set of processes. We feed it deterministic analysis because look, LLMs are not great at dependency management. They're very good at running workflows. So we use an LLM to run a multi-step workflow, essentially do the activity of a developer. But we are doing our proprietary technology in the back end is doing all the deterministic analysis that needs to be performed in order to give the context to the agent that it can then execute on. So it's doing that dependency graph analysis. It's understanding the library, the bundled, the transitives, the first party library relationships. It's building up again an understanding of every single version available. Which version, what are the changes between each version? What is the impact relative to all the usages of that library in that particular code route? So very specific to each usage of the library. And then again, presenting a um, deterministic analysis says, hey, this will either produce a breaking change or not. And then feeding that to an agent, which can then actually, again, make a ticket, create a PR, perform the library upgrade, which is not always the latest, by the way, and may not even be typically a version, but may require some changes to first party code. Run compilation checks to understand have we resolved any breaking changes, really doing reachability analysis to understand with the library upgrade that we perform, does it produce any changes relative to how we use the library? That's the way to think about it. And then ultimately deliver a pull request that contains all this context, all the steps that have been taken, all the testing that has been performed, essentially deliver to the developer this again fully validated PR that can now be merged. Um, that shaves off again years of effort, and it creates an opportunity for developers and security teams to operate from again this shared platform. In other words, the developers can the security team can look and say, hey, look, here's everything we're asking you to do. We know that this will not introduce breaking changes. And if we want to actually focus in and say what's the prioritization of that, we also have a prioritization model that uses um, runtime analysis to essentially identify true risk and exploitability based on the usage of the code and how it's deployed in the environment. But that ultimately is how we are trying to solve this economics problem.
Mm.
Because that's the challenge, is that the cost associated with just getting to the point of understanding that is so significant that instead what we do is just try and prioritize based on some model of risk or reachability, which is not how we want to approach it. Because what that does is essentially encourage technical debt. And the more we encourage technical debt, the more it ages, the more expensive it eventually becomes, and the less resilient our software is. We want to be encouraging modernization and building a pathway to modernization instead of putting in systems that essentially encourage and reward technical debt retention.
Mm. So you mentioned like a few user groups here, then you've got the developers themselves, the application security teams, but equally that whole economics of this. If I'm a developer or an AppSec team, I'm probably not going to be overly conscious of the cost of everything, but you might be my senior manager, even my CFO, C-suite, may be more cost conscious.
Well, it's a hidden cost. I mean, this is the challenge: is that we're not spent. I mean, with the exception of some organizations, that have specific policies or regulatory schemes, right, where they have to resolve all criticals and highs, right? Even then, we can provide them with a lot of benefit because we're taking a lot of the labor away from the developer. But for many organizations, they defer the vast majority of the technical debt, and it isn't. If you go and say how much technical debt do you have, and what would be the cost to resolve that, just in the open source world, no one would be able to quantify
Mm.
because it's just this hidden cost that only ends up getting paid in a few different ways. One, and we hear this all the time from our customers. We were just talking to a VP of engineering who said, earlier this year, well, not this year anymore, last year, I remember it's 2026, they had a opportunity to do something from a product perspective and wanted to take advantage of the latest capabilities of one of the libraries they use, but they were on a 2-year-old version of the library. And the cost of upgrading that library, because they had waited and waited and waited to upgrade, that cost now was so significant that it was a significant interruption to their product development lifecycle just to basically be able to do the library upgrades, to be able to take advantage and build. And so the desire to have resilient software that benefits security because it delivers security outcomes, but it also benefits um, the development organization and the product organization because it really greases the skids for innovation. So when you do want to take advantage of something, you can do it more quickly. And so this idea today is that we allow tech debt to fester and to really just dwell and get older and older and more expensive, and our software become more brittle and less resilient because the cost is too high for most organizations. And our goal again is let's bring that cost down to near zero. And if we can do that, well, then it becomes a no-brainer to embrace modernization. And that doesn't mean going to the latest. It means maintaining, a cadence and upgrade path that allows us to move forward and not have software that, frankly, is susceptible to both security risk or to other sort of challenges that emerge. Um,
Mm.
and that's a very different approach to technical debt when it comes to open source than I think most organizations think about today. Um, and this, by the way, has been exacerbated by AI coding
I was about to ask you
because,
about this. Yeah,
yeah, I mean, look, AI coding, I mean, look, we build software and we've done this for many, many years using open source. It's the building blocks.
yeah.
Well, when you ask an AI coding engine to build software, it uses open source. Um, it is non-deterministic. So if you ask it to build the same application 3 times or the same microservice, it will use a very different set of dependencies. So you end up with fragmented stacks very rapidly because you're not going off of a set of libraries that you commonly are familiar with. It's really going off a set of libraries that have just been almost randomly selected. Um, and then, the challenge is you have less scrutiny on those libraries. Sometimes you're bringing in older libraries because of training cutoffs. So, you have coding engines that don't necessarily bring in the latest version. They may bring in older versions. They may bring in versions that are not well maintained. They may be bringing in versions that have risky licenses. That's receiving less scrutiny because it's just happening quickly. The developer is almost not even really able to evaluate. If it brings in 1,000 different libraries to go and build something, are those libraries ones that you want to bring in? Are you adding significant maintenance costs? Are there libraries you're already using that would be better used? And so dependencies start to pile up, and that hidden cost of maintenance gets added. I think it's estimated that every new library you bring in really brings in something like 20 or 30 hours of maintenance annually.
Wow.
So if you think about a application bringing in, let's say, 1,000 new libraries, that can be a real challenge because you're going to be in a scenario where now that's 20,000, more hours of maintenance. And
It's interesting.
so
Yeah.
the scaling problem associated with that is enormous if we keep the status quo. And so this is really where we think there's this perfect storm of AI coding and open source combining that really creates an unsustainable trajectory, more so than even before. Um, and and then the question is, well, how do we actually resolve that? Well, we can use our proprietary deterministic analysis to solve this in combination with using LLMs. And um, just to be very clear, I want to, LLMs again, not great at doing dependency management themselves. So we're not just wrapping an LLM, right? Um, again, like I said, what we first perform are, the is the deterministic analysis for things like fixability, remediation guidance, safest upgrade path. These are things that an LLM only approach can fall short. So if you just said to an LLM, "Hey, upgrade my library," well, the problem is you're still going to be really dealing with determinism and training, right? So LM outputs again are probabilistic. Identical inputs can produce different recommendations, which is really not particularly useful when it comes to security governance and large scale remediation. And then you have training cutoff limitations. LMs also do not inherently know, for example, your full dependency graph that directs the transits of bundles, which versions are deployed, which environments are affected, how first party libraries propagate dependencies downstream. Without all of that, recommendations are just educated guesses, which doesn't really benefit the developer. Um, and so, what LMs can't reliably determine is like whether remediation is safe to deploy, what the minimum version that resolves all the vulnerabilities, whether transit upgrades will break upstream consumers. This is where what we do is, really build a platform capability. And the value of Healer is that we use an LLM, but it's the LLM that operates inside a deterministic, validated, and auditable system. And that's what allows us to, and really runs our workflow versus trying to make decisions. And so that's how we've really used an LLM combined with all this proprietary tech to really usher in what we think is a new model, right? Which we think of as fix first. And it's really rethinking the problem, right? From prioritization to fixing. So today, there's endless scans, huge vulnerability lists, backlogs grow. With Healer, the focus is what do we fix first by automating safe upgrades, and then really focus prioritization on what is left that requires developer nuance. And if we can eliminate 78% of the security of the technical backlog automatically, then that noise and that frustration really disappears.
Mm. It sounds like a real sort of one-stop shop. And just picking up on a few of the things you've mentioned there around, taking that pain away from development and application security, which we know can be a what's the word? A developing relationship in some organizations, maybe, but
Yeah.
also the economic side of things. But the bit that I'm sort of hanging on to here is that it can be a genuine like business enabler, enabling you to innovate. Going back to that
Yeah.
age-old security can be a business enabler. This sounds like it really does that in like kind of a
Yeah.
one-stop sort of fashion.
Yeah. I mean, the important thing to recognize is like we're talking about tech debt, and tech debt is something that slows innovation.
Mm.
Security risk is just part of that technical debt component. And so fundamentally, we are in a situation where we can help both the security outcomes, but also, again, just the pure resilience of the software itself. Um, and I think, the economics are what we're trying to solve for, because that's the thing that holds people back. I mean, this is the thing, is when we think about application security, we have to think about it as an economics problem, that the unit cost of fixing is too high. And in order for us to really scale AppSec, to really achieve resilience and to eliminate technical debt, that is where we have to reduce the unit economics, the cost of fixing, to near zero. And if we don't do that, and we have to do this in a way that actually builds resilient software, so performs the library upgrade itself, right? There's what people have done, again, as I've said, as a way to sort of avoid this, is they've taken this idea of prioritization, right? Because prioritization allows you to get to a smaller list that might be manageable by an organization, right? But again, and the reason we're doing that is because the cost to fix is so high that we're basically saying, hey, let's try and get to the smallest list we think our developers can actually manage. Well, that's not the right approach, right? Ultimately, it just encourages tech debt. It encourages deferment. And the reason that we do that is not like because people are trying to avoid resolving tech debt. It's just the cost is too high. And so, as long as that cost is too high, the natural state will be to defer. I mean, that's what every developer can do. It's going to say, right, because that constant pressure to deliver timelines. But every deferral increases risks and multiplies the cost the organization will eventually have to pay to resolve that. And that's the cycle that every engineering and security team is trapped in today. Not because people don't care about security or building resilient software, but because the current approach makes modernization nearly impossible to scale. And that's what we want to be able to do.
Yeah, it's
Right.
cool. I
And
mean,
so,
cool.
yeah, yeah, go ahead.
I was going to say, it's founded in 23. We're clearly off the ground here, and things are happening. And I'm sure there's plenty of solid customer success stories in there. But I was going to ask you, all this does seem like genuine no-brainer. It seems like extremely positive things. What are your
Yeah.
customers saying around the product? And I guess, is there anything in there that's been a bit of a surprise benefit, perhaps, that you maybe didn't consider when creating
Yeah, I
it?
think, look, as with any application security tool, introducing a new experience to developers is a change management process. And so it's about building trust, right? It's about starting, um, with um, easy wins, with security champions that are embedded, and demonstrating the impact that you can have on this. Um, and so, from that perspective, um, it's been a very, it. I would say that, like, it moves a little slower than you'd like, but
Okay.
then you do then hit that hockey stick within customer adoption. Right now, the good news is there's lots of things that we do beyond this to help developers and security organizations. And so, we have guardrails. We do have prioritization. Right, we actually have a lot of tech that is useful just to around other things like secrets and SAST and other components. Um, and so there are immediate benefits that can be adopted very quickly. But it is a function of where you have to go in and win the hearts and minds of developers, right? Because without developer trust, you won't be successful. I think what we really lean into is how do we build a product that engenders customer trust. So if you think about what our agent does when it produces the ticket, when it produces the PR, it contains a comprehensive set of information about both why the agent took the actions it took, what the impact is, and what steps have been taken to ensure that it's a valid upgrade that will produce verified and non-breaking results. And by including all of that transparently and embedding this in the developer workflow, so they're not coming to Healer to interact with this. This is all through their existing workflows, through ticketing,
Okay.
through PRs, through commenting. That really allows us to um, deliver an experience that developers feel much more comfortable about. And once they start using it, it becomes a no-brainer. And in fact, I mean, we just had a customer um, we were talking to yesterday that was talking through the difference that was, from a month ago prior to adoption of Healer to now, and how substantially their workflow had changed. And ultimately, they're like, look, we can actually scale like what used to be this disorganized process. And they were talking about how actually, in the past, you had this scenario where, the AppSec team, was aware of certain vulnerabilities, but then developers were getting emails about some of their products and saying, "Oh, I saw this library upgrade that I could go do, um, and should we go like research that?" And it was just this sort of disorganized mess of like, well, how do we set priorities? What libraries are actually ones we should be spending our time on right now? And getting to the point where instead you could simply say, hey, here's our plan of action. Here's our most impactful remediations off the bat. Here's the ones that we can auto remediate based on those. And then have a working plan that everyone can operate from. And that's part of what we do. We have these really specific, what we call workbenches that build out essentially the plan for both AppSec and the development teams on where they can spend their time, even just from an automated perspective. And that's been an enormous change where everyone now is operating from the same perspective. Everyone's moving in the same direction. It's become much more orderly, and they were just celebrating just the reduction of the churn and the noise and the communication that's been required in the past to manage the process. And that's where we go back to that shared operating platform. That it really helps provide clarity, and people like clarity. People like knowing what they need to do and why and how. And I think that's part of the challenge. And then taking away the cost associated with that, well, that's just a big win. Because now we can actually start, making improvements and engaging in a way that previously was impossible.
That sounds awesome. And all that within inside a month, you said.
Yes, correct. Yeah.
Wow. I mean, I know of plenty of technology platforms out there that you sort of see the value 3, 6 months in, you start seeing it, and over time it sort of builds up. But if that's the kind of numbers we're playing with, then yeah, it sounds pretty cool. What was the just to touch on like the whole growth of Healer so far? I know we're pretty early days still, but we're obviously growing pretty quickly. Like,
Yeah.
what's been like a sort of was there ever a oh my goodness, we've really got something here. Let's scale
Yeah.
this moment. Did that happen, or was it always been pretty sort of go
Yeah.
go
It was
go?
interesting. I'd say that people were skeptical of agenic remediation
Hmm.
up until about last year. What I would say. It's funny how, look, not developers. Developers have been using LLMs to build software and even perform upgrades, you know, um, well before, you know, last RSA. But from a security team perspective, was a paradigm shift post RSA where I guess enough people got in the room and realized that if developers are already using these tools to try and solve this, and that's what we see regularly. You walk in, developer goes, well, I were using LM to try and do some of these upgrades. You know, sometimes it works, sometimes it doesn't.
Hmm.
What makes you different? And our answer is, well, we're not using an LM to perform the upgrades. We're performing an analysis, doing all this, and they look at it and go, oh yeah, that's not an LM is really the workflow agent. Um, the I think the trick is that coming out of RSA, security teams really said, hey, if our we need to embrace this also. We need to find a way to scale. And if developers are already embracing this, why aren't we?
Yeah,
Yeah.
yeah, yeah, makes
Why is there
sense.
this asymmetry? Uh, and that really, and I won't say that everyone has gotten there. You certainly talk to some organizations that are still very skeptical, but it really was a big difference, and that continues to sort of be like when the proverbial snowball rolling downhill. It's more and more people looking at this, and the other part is I think people have really understood that prioritization as the model for security is just flawed again because it just encourages additional technical. And there have been some. approaches. People will say like, oh, but like Men Renovate or Dependabot are out there. They've always done library upgrades or PRs. But those are really products that were focused on also what I would call like blind upgrades. They're not doing the analysis to determine breaking changes in any real, in terms of like your usage of the library. They're not validating upgrades. They're not building out the dependency graphs, things around first party libraries, transitives, at least not Benabot. The And so from that perspective, we've seen a lot of customers that had adopted some of these technologies like a dependent bot or a renovate. Which are great products, but ultimately did not deliver the value to developers relative to the things they were producing. They were almost glorified ticket systems, and they really want to embrace the ability to do more and to arm developers and to help the developer. And the idea of us delivering validated PRs, not blind automation, really resonates with them. And so we've just seen a lot of folks adopting based on that.
That's awesome. And so, as you touched on it earlier in the call, we're just at the start of 2026 here. I think where are we
Yeah,
at? Jan 7. So
yeah,
the next 12 months, what's that looking like from your perspective?
yeah. I mean, we're just going, look, today we can handle 70 to 80% of upgrades automatically. We want to get to where it's 95%, right? And so we are going deeper and deeper into what we would think of as like, so we can solve breaking changes. The agent will actually again make first party code changes to resolve set of those. We can't do all of them, right? There are some that today still require a developer engagement. But we're continuing to build out the proprietary technology that allows us to unpack um, really some of the complexities. And this comes into things like bundle dependencies, first party libraries, the complexity of the upgrade path, because you have to upgrade multiple different files and it has to be rolled out in a particular cadence. And so you have to walk the dependency tree. And our technology allows us to do that. And it's just a function of being able to feed in the right context into our agent to allow it to really drive through that. And so our goal is really to just go deeper and deeper into the agentic remediation side of things, and continue to really uh, enable our customers to um, uh, to eliminate more and more technical debt, frankly, on an automated basis.
It's awesome. Well, if we're at 80% already, then 95% is around the corner, it sounds like.
Yeah, I mean, look, we feel very confident, based on the initial tests we're running, and we're piloting some of these more advanced ones with our customers. Yeah, it's exciting. I mean, look, it's exciting to have a product that really has impact and isn't just putting a band-aid on the problem. And we think like, ultimately, the prioritization only model is really not one that ultimately is going to be successful. And it's really about delivering, you know, outcomes that allow you to actually perform the library upgrade itself and not produce a breaking change and have confidence of that. And if we can, and by doing that, we really change the economics of the problem, and we really change the ability for organizations to be much more resilient with their software.
Mm. No, it sounds really exciting. It sounds like 2026 is going to be huge, and like you
Yeah,
say, everything from the economics to the security to the innovation involved. It sounds like a very exciting time to be. So we'll chuck all the links and everything below the episode and the links.
yeah,
Chris, above all else, thank you for jumping on. I know it's early Jan, you're
yeah.
probably flat out, so great to have you.
Thanks for having me.
Cheers,
Talk
Chris. Take
soon.
care now. Bye bye.